Okay, so satu lagi aplikasi second formula ni, okay, which is f prime x equals to limit of x approach a, okay, fx minus fa over x minus a ni adalah untuk determine whether the function is differentiable or not. Okay, differentiable. Okay, kebolehbezaan. Okay, so to determine whether a function is differentiable or not, okay, f prime a, sorry, this is not fx but f prime a. Okay, f prime a must exist. Okay, so if f prime a exists, that means the function is, so fx is differentiable. Okay, to determine whether the function the derivative is exists or not, okay, since x is approach a, so that's mean kita kena determine whether, okay, limit of x approach a from the left is equal with limit of x approach a from the right. Is equal, that's mean f prime a is exists. If not equal, that's mean f prime a doesn't exist, which mean not differentiable. Alright, so we're going to look at this example here, example 3. Okay, so given the function fx is equals to 2x for x less than 0 and x squared for x greater than 0, can determine whether f is differentiable at x equals to 0 or not. Alright, so to check whether this function is differentiable or not at x equals to 0, so we need to determine whether f prime 0 exists or not. Alright, so to determine whether the function exists or the derivative exists or not, so we need to find the limit. Okay, we're going to use the formula, which is limit of x approach a, okay, from the left, okay, and also limit of x approach a from the right. Okay, kita nak tengok dia sama ke tak kiri kanan ni. Okay, because a piecewise function, it can be the same or it can be different. Okay, so if I draw a number line, okay, for the function, okay, 0, when x less than 0 we use 2x, for x greater than 0 we use x squared. So for x approach a, so a is 0, so we're going to find the limit of x approach 0 from the left. So from the left we're going to use, okay, from the left is going to use 2x. Okay, and from the right we're going to use x squared. Alright, so from the left we're going to use fx is 2x, so fx is 2x minus, okay, this is f0, so f0 means we substitute x with 0 over x minus 0. Okay, so what we get here is 2x over x. Okay, and we can eliminate x, so what left is 2, so the limit is equals to 2. Right, so from the left we get 2, and from the right, okay, limit of x approach 0 from the right, so fx is x squared minus, okay, fa or f0, f0 means we substitute x with 0 over x minus 0. So we get here is limit of x approach 0 from the right is x squared over x. So we can simplify this. This is equals to x. So if we substitute x equals to 0, we get 0. Alright, so what we have here is limit of x approach a from the left are not the same with limit of x approach a, which is 0 from the right. Because at the left we have 2, and at the right we have 0. So that's mean, okay, f prime 0 is not exist. Okay, which mean fx is not differentiable at x equals to 0. Okay, so that's how we determine whether a function is differentiable or not at a particular point. Okay, so maybe another example here, example 4. Okay, given the function fx is negative 2x minus 1 for x in between negative 2 and negative 1, and x squared for x is in between negative 1 and 2. So we need to determine whether the function is differentiable, whether f prime negative 1 exists or not. So we need to find, okay, f prime negative 1. Okay, alright, so to find f prime negative 1, since this is a piecewise function, okay, at negative 1, okay, negative 2, 2. So between negative 1 and negative 2, we use negative 2x minus 1. And between negative 1 and 2, we use x squared. So that's mean from the left and the right are not the same. Okay, not the same function lah. So that's mean kita kena cari limit of x approach negative 1 from the left, and also limit of x approach negative 1 from the right. Okay, and we use this formula fx minus f negative 1 over x plus 1. Ini bersama lah. Fx minus f negative 1 over x plus 1. Okay, so for x approach negative 1 from the left, okay, we're going to use negative 2x minus 1. When x approach negative 1 from the right, we use x squared. Okay, so for this function, for this one, at the left, kfx is negative 2x minus 1. Okay, this is for fx. And then minus, okay, f negative 1, we substitute negative 1 to x over x plus 1. Okay, so we can simplify this. So this is equals to negative 2x minus 1. And this is equals to k2. And this is 2 minus 1, which is 1. So minus 1 over x plus 1. Okay, so negative 2, that is equal to negative 2x minus 2 over x plus 1. Okay, if we substitute directly the limit, we get 0 over 0. So that's mean we need to factorize. So we can factorize x minus 1, x plus 1. So limit of x approach negative 1. So this we can factorize negative 2. So what left inside is x plus 1 over x plus 1. So we can eliminate x plus 1. So limit of constant is just that constant itself, which is negative 2. Okay, so from the left we get negative 2. Now from the right, okay, limit of x approach negative 1 from the right. Okay, the function is x squared. So x squared minus negative 1 squared over x plus 1, or this is equals to limit of x approach negative 1 from the right is x squared minus 1 over x plus 1. If we substitute directly negative 1 into this function, we get 0 over 0. So that's mean we need to factorize first. So we factorize. So at the numerator we get x plus 1, x minus 1 over x plus 1. So we can eliminate x plus 1. So we left with x minus 1. So if you substitute Okay, negative 1, x equals to negative 1, we get negative 1 minus negative 1, which is negative 2. Alright, so what we have here is limit of x approach f prime a from the left and right are the same, which is negative 2. So that's mean f prime negative 1 is exists, which is negative 2.